afternoon, everyone. So, welcome to the webinar. Warm welcome from IEEE Computer Society, Bangalore chapter. Myself, Vishwas, the chair for Bangalore chapter, and Anand, the secretary, will be hosting the session. And this is part of our Celebrating Computing webinar series for 2020. During the month of May, this is the second session. Last week, we had session on writing research paper, and next week we are having another session on AdaSwarm, a PSO optimization method. So the invitations are sent out usually a week in advance, and you can also visit our LinkedIn, Twitter pages as well as Facebook pages for all the updates. So this is the second in our Celebrating Computing series, and we are very glad to welcome Dr. Sanjay Ghosh, who is currently user experience researcher at Google Bangalore. And he will be talking on cognitive modeling in human-computer interaction. And the case study is focused on decoding typing behavior by users. So Sanjay holds a PhD from IIT Mumbai, IIT Bombay, and MTech from IIT Kanpur. He has previously worked at ABB as well as Samsung. He has applied for more than 20 patents in this area and also published extensively in top HCI journals. He's a known expert in cognitive modeling as well as HCI, and it would be great to hear him out personally during the next 1 hour on this topic. We will anyway share these details at the end of the session so that you can keep visiting and following us, and for all the updates of all the events that are coming up in the near future. So with this introduction, I hand over the virtual stage to Sanjay. Sanjay, it's a great pleasure for Computer Society in hosting you today, and it's a privilege to have you deliver this webinar. And for the next 55 minutes to 1 hour, we'll have the session, and then it will be followed up by a 15-minute session on question and answers. So over to you, Sanjay. You can.
Uh, Before we begin, all participants kindly mute yourself and switch off your video. You can post your questions on the chat window. The speaker will answer those questions in the Q&A session following the presentation. Thank you. Over to you, Sanjay.
Hi, this is Sanjay. I just got disconnected, so I hope everything is fine now. You guys are able to hear me, see me as well. Can you just acknowledge
Yes, we're
that?
able to hear you.
Perfect. So let me pull on my presentation.
Sure.
I was in almost 50 minutes ago and just got disconnected. There is some problem in my uh, internet in my home. I know everybody is working from home, and this happens. Anyway, uh, it's been a pleasure really to be speaking in this platform in front of so many people. And from the introduction, this is the second um, talk in the same series, celebrating computing webinar series of this year. Really fortunate to be speaking on this. The topic of today's talk is around cognitive modeling, and what Vishwas just gave as an introduction. That I work in the area of human-computer interaction here at CI. A lot of us know that it stands for human-computer interaction. What I'm going to do in today's talk is introduce a method which is cognitive modeling. I've used this method for my research, and therefore I'm going to share some of my experience in that. It's not more of a theoretical talk where I'm going to only explain a method. I'll also show a case study on a specific topic so that you can understand how to apply this to real world problems. And again, I mentioned that this is in the area of design for technology. So, as an introduction, I have been a technologist earlier in my start of my career, and now I have turned into a design researcher. And I believe from my experience in the past few years that these two things, these two disciplines work hand in hand. Unless these two disciplines and people in these two disciplines work hand in hand in the product, we don't get a successful product. So therefore, this talk is for designers. It's also for technologists, researchers. Let me just confirm once whether everything is
Yes, it is visible now.
correct. Yes. Anyway, I was just on the panel page itself. And this is so we are starting now. Okay, so
I guess the presenter view is on for us.
uh, is my screen visible to everyone?
Yes, the slideshow is visible. I think it is in presenter mode for us.
Yes. So I should continue like this. Is it okay?
Probably you can just change it to the presentation view. I mean, you can switch off the presenter view using the three dots on the screen. That button next to the.
Uh, so I'm presenting already. So what should I do now?
Yes, the presentation is visible.
Yes.
When you put it to presentation mode, it goes to the presenter mode. Like we see the two small screens. The next slide also.
Okay. So
Sanjay, yeah, button, yeah.
is this fine?
Yeah.
Yeah. Yeah. I got something related with the WebEx. Okay. So let's start now. If everything is perfect. I'm in the first slide where I'm going to say that what is my attempt, what I'm trying to attempt in this session with you all. What I'm going to do is I'm going to introduce cognitive modeling as a method, as an approach, which is used for working with design and technology together. It's a user-centered design methodology, which I'm going to talk about. The
Sanjay,
second,
just to interrupt, if you can go to the full screen mode, uh, the third button, yeah, that one, yeah, please.
this is in the slideshow, right?
Yeah, I guess it's on the other screen. We are seeing the PowerPoint.
Okay. Okay, let me put it off and put it in again.
Yeah, just a minute.
Because is this fine now?
Again, we are seeing the PPT actually. Can I just quit the slideshow and again start it?
Okay, let me go back and stop sharing and then let me see.
Sure.
This is the problem.
I think it is because of the two screens, so it is probably switching between them.
Yes, I'm actually using two screens, so is that a problem? Is creating the problem?
Yeah, because what happens is when you share the screen, it switches to the other screen. So the PPT goes to the other
Okay.
screen and the PowerPoint stays here. The slideshow goes to the other screen and PowerPoint stays here.
Let me see. I've removed the other screen now, and I'm going ahead and presenting now. That works. I guess this should work now.
You can just try presenting your screen now.
Yeah.
Thank you.
Does this work now?
Yeah. Yeah.
Yeah,
Perfect.
it's perfect. Yeah.
Perfect.
Yep.
Okay,
Yeah. Great. Thank
fine.
you.
Sure. Yeah, so just let me know if something is not visible or if you're not able to hear me. Just
Sure.
interrupt the time.
Sure.
Okay, so I was in the slide. I came to this again. So what I'm talking about here is what I'm going to try and attempt in this session. This session is around 45 to 50 minutes session where I'm going to present. Um, I'm going to introduce the topic of cognitive modeling, which is an approach, which is a method of designing and technology building together. My another attempt is that few people feel that this topic is pretty complex because when in academics I learn this topic, or sometimes I teach this topic in few of the institutes, it feels like people say that this topic is pretty complex. So I'll try and make it a little simple, make it very interactive, so that people can appreciate the use of it. They can apply this in their problems, real life problems. And I'm not going to leave this to the level of theory, not just the theory of the methodology, but I'll also try and show how to apply this in real world problems by showing a case study, something which I have done as part of my research. And another thing is, yeah, so my introduction, what Dr. Vishwas was saying, I work for Google right now, but the work which I'm going to present right now is some of the research which I have done as part of my doctorate. It's independent of any company. So any views presented in this topic today, uh, do not consider this to be a view of any company or any corporate way. This is some research. I'm just giving this talk for educational purpose so that people can do research in this area and contribute to this area. Well, so I'm going to start with this video. Just listen to this video. This video is this guy is Don. Probably some people might know him. He's the most influential design guru and very much highly followed person in the area of design. Let's see what he says. This is going to build a background of what I'm going to talk about.
Dr. Sanjay, I guess the audio is not coming through.
Uh, how do I play the video then in the screen because I'm right now playing it. So how do I play it?
If you have the
If you have a
presentation,
link,
yeah.
you can
Okay,
probably, yeah, share content, or probably the share web browser option. You can directly share it, or share multimedia. You have the video.
okay. So what we can do is just for the sake of time, let me skip this part then because it has already spent some time on the video connection issues. So we'll lack time then. What we'll do is it's okay. I'm going to give the gist of what this video is all about. If you can see if you can actually see the presentation, this should be fine, right?
Yep.
So the person is Don Norman, and what he says in this video clip, I can share this video later after the talk. This will save us some time. Um, Dr. Don Norman, what he says is technologists and designers should work together because technology, if it is not for user, it just stays as technology. It is not put to work. So for a technology or a technologist to create a great technology or any useful technology, it is for the users. It is for people out there. Unless people out there use it, it is of no use. So that's the gist what he says, and it actually builds the context of what I'm going to speak about. He says that technology should be built for users to use it. I'm in the next slide, where I'm showing that these are the three, the biggest companies on earth today. And what I've written down here is their number one philosophy. There are some philosophies each of these companies, big corporates follow. These philosophies are for their business, these philosophies are for the development of technology, it's a philosophy for their people, or their employees, and to survive in this world. If you see something common across all the three big companies, and their number one philosophy is this: their customers, their users, and people who use their technology. Therefore, all of these successful companies focus on their customers, focus on their users, and they develop those technologies which are really useful for people in the world. Now, what I'm showing on the screen right now, probably you might have heard, this has been used as a technology many times in the industry. There are courses which teach this. The usual practice of building something, uh, developing a technology, is called user-centered design, where designers and technologists, developers, everybody in the team work together. Now, user-centered design as a methodology is what? It's a methodology where if you design something, you prototype it, you implement a part of it, you evaluate the same technology with the users out there, the real users. And this process goes on and on in spiral form, which means you will design again, you will improve your design, you will implement it again, you will again go back and test with the users, evaluate with the users whether the technology for which you have built, are the users able to use it or not. So this is the user-centered design method. You always put in this method the users in the center, and that's why you call this as user-centered design method. However, there is a lot of weightage attached to this. By testing with the users is a gold standard. Every company does it. Every product, every successful product out there must have been tested with many users, and then it came and got released for the world. But in order to do this kind of method, it has a lot of weightage, as I said. It is time consuming. It is expensive to do so much of testing. It also has a lot of human sample biases because you can only test with only limited set of people. And there has to be a limit to how much time you would test it. You cannot iterate and test for a longer duration. You need to release the product very quickly to the market. So the question to be asked here is whether whether it is possible that there are some simulated models or there are some programs which can help uh, predict how users will use the product. Can I use those simulated models so that I don't have to do user testing? Can it replace the user testing in the world? So that is where cognitive modeling comes into picture. So what I'm talking about here is the conventional method in user-centered design is testing with a limited set of users, a sample of users. On the other hand, the cognitive modeling as a method, what it does is prior to testing, what you do, you create your models. How would you create these models or create these simulation programs? Is by testing with even bigger chunk of users, various set of users, real users, and then create your simulation models and use it to test your product later. And you can iterate on your product through these cognitive models which have been created. So this also is a part of user-centered design method. But what it says is test with a huge set of sample, create this model, and based on these models, you can test later. You don't have to iterate. We are saving your time that way. Now, that is the introduction for cognitive modeling as a method. Basically, cognitive modeling is what? It's an approach to design for technology. by keeping again users in the center. It's again the user-centered design method. Um, so the premise is that we have to ask the question that really is it feasible to derive computer simulation models of humans thinking process? Because humans, we human beings are very sophisticated biological, probably machines, we can say. We can think, we can memorize, we can process, we can act on things. Our brain is very, very complex computation device. So how we can model what we should be thinking, how we should be working, what are the actions a human being would take. That is how that is the premise with which cognitive modeling as a method works. So cognitive modeling is a research methodology which involves design of computer simulation models or mathematical models which represents the human cognition, human performance, and human perception. Now, it attempts to replicate what we human beings are, but it is not possible to replicate directly because we human beings are very complex computing systems. The premise with which the cognitive modeling as a methodology has been developed as a as a field in human computer interaction is that thinking whatever thinking process goes inside our brain is kind of similar to what goes inside a computer because we human beings are also composed of inputs, outputs, processing, and memory. So a schematic picture like this can closely represent what we human beings are because we have our cognitive process, we have our short-term, long-term memory, we have our processing memory, we have our auditory processors, we have our sensors, and we have these actuators, our hand, our legs, our tongue. All of these are different units which can have an analogy to a computing system. So, in a way, if if we are saying that there is an analogy of human beings to computers, and if in computers you can always measure things, if you can benchmark things, same should be a way that we should be able to measure or benchmark how human beings would act, how human beings would think, and how human beings would perceive certain things. Therefore, for cognitive modeling as a fundamental field believes that human performance can also be modeled. Now, the good thing here is that the cognitive scientists, so this is an old discipline, age-old discipline. The scientists, cognitive scientists, have already modeled a lot of fundamental matrices which human beings and human performance form. For example, a lot of things have been already measured and benchmarked. Things like how much time does it take for a human being to bring something from their long-term memory to a processing memory. Uh, it has been already benchmarked. How much milliseconds or microsecond does it take? Now, at present, what cognitive modeling as a discipline does is we try and see which types of these existing models are applicable to our scenario, our real world problem statement. We use those, we customize those for our problem statement, apply those, and then define our problem statement, things which we want to measure based on that aspect. So that is what is the discipline of cognitive modeling. As a discipline, yeah.
Yeah, we actually have a request saying if you could please turn off your video because your voice is breaking. Sorry to interrupt you.
No problem. I will do this. Systems. I have turned off my video and I'm proceeding now. Okay, so as a discipline, where cognitive modeling lies is it has an intersection with artificial intelligence. It has an intersection with machine learning, because all of these disciplines tries and attempts to advance what human beings think based on different situations, and also tries to predict how human beings would act at different situations. So this is the overlap between the disciplines. Um, so as I said, cognitive modeling as a discipline is a set of different models which already exist. For example, there are a lot of theoretical models on one side. There are some metaphorical, analogy-based models, which is more descriptive in nature. On the other hand, there are more of specific mathematical equations. So, what model is basically it is a simplification of a phenomena which is happening in real time, and our ability to understand this, represent this, and predict the behavior, how people will use it, what phenomena is there in the real life. That is what a model is. So any description of a model could be either mathematical, very specific description, or it's very theoretical in nature. I would say all sets of models which exist in this space are in a continuum, whether it's very specific in terms of mathematical or it's very theoretical. Therefore, there are two types of model as well in cognitive modeling. Two types we can classify. One is more of descriptive model, more theoretical. Then there are few predictive model. What we are going to focus today in today's talk is on more of predictive model, and therefore you can understand there will be more of mathematical equation-based models than more of theoretical models. So what I'm going to introduce now is few examples of these models so that this is clear that what this is, and later on I'm going to explain how we use those. Then things would fall in place. Uh, Now this video, I know the audio for this video may not work, but this does not have an audio. I'll just play it, and it is going to introduce the first mathematical model, first predictive model. You can just watch the video, and then we'll see. You would see this person is doing some experiment, a very mundane experiment. He is moving his hands from a source to a fixed destination. But what he's also trying to do is he's changing the distance between source and the destination. And the second thing is he's also changing the size of the stimulus. Did you observe any physical phenomena which was happening? Well, I think you might have observed that when the size of these targets, the source and the destination, the stimulus, were large, he was able to move his hands very fast. When it was small, he has to reduce his speed. Again, when the distance between these two were large, his speed was large. His speed was
Sanjay?
fast. Yeah.
Yeah, again, I'm sorry to interrupt. The slide hasn't changed from previous one, the ninth slide.
Okay. The ninth slide, are you sure?
Yeah, we are on the ninth slide right now.
I'm
Sorry.
sorry, I don't know what this. This is being presented. I don't know. Is it fine? Are you able to see slide number 13?
It hasn't changed yet.
No,
Sorry, there is a lot of
not
trouble in
yet.
the.
Yes.
Okay, let me then. So my side is everything working fine. So let me again stop sharing and then start again. I'm very sorry. I don't know why this is happening.
No, it's fine actually. So,
I'm really sorry. It would have been best
no
if
issues, no
I would
issues,
have presented it in person. But really sorry. Because
no issues.
please interrupt me whenever you feel like this. Because I don't know whether you have not seen the slides from 9th to 39 or from 9 to 13. So next time onwards, I'm going
Yes.
to. Okay, so next time onwards, I'll keep saying that I'm moving to the next line.
Sure.
Is this line now?
Yeah, I think, yeah, we can see the slides, not in the slideshow mode, but still, yeah. Yeah, we are on the 12th slide. 12th
Yes,
slide.
I've moved from here. I was speaking about the mathematical models and the descriptive model, the theoretical model. I'm sorry that so next time onwards, if you feel that you're not seeing the right slide, please let me know so that you don't miss out things. You
Sure.
don't waste time. I'm also going to say that I'm moving to the next slide. Uh, okay, so this is the first mathematical model which I'm going to present. I'm in the slide number 13, which shows a picture of a person and he's doing some experiment. This has a video. I'm going to play this video. I know the audio for the video won't work, but let me play this, and then you would see that there is some phenomena happening in this experiment. I hope you guys are able to see this. Again, what I'm going to repeat again. The phenomena which is happening here is that this person is moving his hand from a source to a destination. He's changing the size of the stimulus and he's changing the distance between the stimulus. The physical phenomena which is happening in the background is that when he is changing the size, he's moving from a small stimulus to a to a smaller destination. The time with his move he is taking, or the speed at which he is moving his hands, is changing, and there is a physical phenomena which happens. It is defined by this phenomena, which has been called as Fick's law. By the way, the name of this scientist is Fitz. There is an S in his name, therefore the name of the law is called Fitz's law. So the phenomena is what? It says that the time of movement between a source to a destination. This is a phenomenon related to movement, a movement of a finger, movement of a hand, movement of a leg, anything. So the experiment which Fix did several years ago on a physical experiment test bed proved that the time of movement between a source to a destination is dependent on two facts. One, of course, is the distance between these, and the second one is size. Because you can see that when this person who was doing this experiment, when he was moving to a smaller size object, he there was his mind was able to make in order to achieve the accuracy so that his finger lands on the right object. He was reducing his speed. Therefore, there is a trade-off. His mind was able to create. His brain was able to make a trade-off between speed and accuracy so that he is able to achieve the target. So our brain does these kind of complex phenomena. We should be able to measure it, and through by measuring, which means we should be able to model it the way Fitz has done this modeling. Now, when Fitz did this experiment several years ago, he did this on a physical object. But this is applicable, really applicable to many, many different things, even in the digital world. Let me give you an example. I am in slide number 15, which shows there is a question. Ideally, if we were face to face, I would have put this question to the audience, but then you can take this question on your own during this webinar. What I'm asking you is based on what we just saw, if we apply the same phenomena on these two interfaces, these are two desktop interfaces, web browsers. These are email clients, design number one and design number two. And the question here is, which of these interface is faster if you want to move your mouse cursor and create a new email, design number one or design number two? Well, from Fitz's law, we just saw that bigger the target, it's easier to achieve. You can achieve that faster, which means your design number one is better than design number two, because the button which says compose is bit bigger than the button which says new. So it's easier to get to that interface. Therefore, Fitz's law applies to many, many different things. It's not just in the physical world, but also on the digital world. And another example, I'm in the slide number 16. Again, the same type of question. What I'm showing here is two interfaces. On the left hand side, there is an old Windows Notepad interface, which has file, edit, menu buttons. And on the right hand side, there is Mac interface, which again has these file, edit, menu buttons. So the question here is, if there is a user who wants to go to, sorry, is there a question? Okay, I'm proceeding now. If a user wants to go take his mouse cursor to the button edit, uh, on which of these interface would it take lesser time? We just saw the previous example, and from the phenomena we know that bigger the size of the target, faster it will be. The user would take less time in that way. Going by that logic, the user would take lesser time to go to edit in Windows Notepad interface. Mac people are intelligent, they're great designers. They must have done something else. They have made use of the same phenomena, same law in a different way. I would say the answer to this is not the Windows one. Rather, Mac interface would take lesser time because the way it has been designed, uh, edit button on, on Windows interface is really big. So ideally, going by this design, it should take lesser time. But if you say, if you see on the Mac, on the right hand side design, the option is exactly at the edge of the screen, which means if you move your cursor, it is not going to flow away from the edge of the screen, which means you are not worried. You can attempt that stroke very fast. Your mouse cursor is not going to flow away from you. Therefore, you can increase your accuracy, still having good amount of speed, which means these kind of design helps you, which means these designers should be able to understand and use these kind of laws, these kind of phenomena which exist. And technologists should be able to implement that in such a way that it makes things easier for the user. So therefore, there are some exceptions to these laws as well, which plays its role. So what I'm saying is, laws does exist, these kind of models does exist, but it is important for us to apply it to our problem statement, what our problem statement is, make use of it. And another example, you must have seen these kind of menus in different web pages, different apps. The question here is, going to which of these menus is faster on an average? Like going to a list menu is better or faster, or a pie menu is faster. So going by the same logic, one might say that going to a pie menu is faster because if I want to choose a particular day, say a Tuesday, then it's easier. My distance movement is small, my targets are bigger, therefore I can move my finger on a touch screen faster. If I'm moving my mouse on a screen, I can choose the pie menu faster. But it is bigger targets and less distance, of course. But if I say that if I increase the number of stimulus, then what would be the answer? Is it always holding true that the size of the target and the distance between your start and the end point does matter, or is it something else? Something else is basically the number of choices. So we human beings, we are a strange being. Like we always look for more and more choices. We always are happy if we are given more number of choices, more number of options. But given so many options, which lies in the same hierarchy, we ourselves get confused, and it becomes very difficult for us to take decision. So the point which I want to make here is, uh, It also depends upon how many choices you have in an interface, in physical world as well. Your time to choose one particular choice out of n choices would depend on really what n is, how many choices you are given, and based on that, how many you have to pick. So this again is a second phenomenon, second model, second base model which I'm going to introduce. The first one which we saw was related to, which we call as Fitch law, is related to your movement of your hand or movement in the physical world. And we saw that the size and the distance really matter. This is the second law, which is called Hick-Hyman's law, which says that the number of stimuli, number of choices which are given, that determines how much time you would take to choose between them. Now, this is an obvious thing. We would know that this is pretty common sense that given more number of choices, human being would take more time. Why a model for this? What 60 years ago, what Hick and Hyman did is they did they did came out with this model by rigorously doing longitudinal testing with different types of users, different types of subjects, through different types of stimuli. These kind of test beds, physical test beds. Based on that, they came to a conclusion that it has a logarithmic behavior, which means the reaction time of human beings has a logarithmic relationship with the number of choices they get. Now, we would say that each of we human beings are different. So for example, I would be able to make a decision between 100 different options in so much time, which my grandmother would be able to take a decision within only 10, because my IQ level, my reaction time, my response to certain things would be way higher than, say, my grandmother. I do have something which my grandmother may not have, and because of that, my reaction time is better. So definitely, there are different set of you would see biases, you would see variations in terms of the user responses. But given a single user, given a particular user, that particular user would saturate that the reaction time of that particular user would saturate when you increase the number of students. That's the law. That is one of the model, a base model. But where does it apply? It does apply to things like quick decision making, simple decision making. When there are so many options, you need to take a call. It doesn't apply to situations where you are trying, you have a menu card and you want to choose which burger you want to eat, because that's a complex decision making. Because you are doing extensive thinking, you are thinking too much. Hick-Hyman law does not apply there. So again, I will come back. So I'm on slide number 20. I'll pause for a while and just ask you everything is fine in terms of the VC, in terms of the slides. Can I get an acknowledgement? Can I get an acknowledgement, please?
No?
If everything is going fine?
Yes, we are all good.
Okay, good. So I'm in slide number 20. Uh, the question again here is, we were thinking about different number of choices, but the question is it only the number of choices, or there are a few other things which determine how much time we take to react to certain things? Um, let's do an exercise. Ideally, this exercise we could have done face to face, that would have been the best, but let's do it all alone, ourselves. This is an exercise, a small exercise which we do just to appreciate and see how our human brain works and how our reaction time changes to certain things. So this exercise is just about, I'm going to show you some jumbled up letters on the screen, and I'll just give you just 1 or 2 seconds so that you can remember how much you. let's see. Let's play this all alone ourselves because we are on webinar. Uh, let's see how it goes. So you can anticipate that there will be some characters which will appear on the screen and you will be able to remember that. Let's do it. So here you go. And our time is over. So I'm not sure how many of these do you remember? Probably three, four, maybe not more than that. Maybe somebody might be able to remember six or seven. But it's very difficult to remember all 12 or 15 letters which I should. Let's do it again and let's see what's the difference. And then we'll be able to appreciate how a human being mind works. These are the same letters. Was our response better? Are we able to remember more? The thing which I did this time is I chunked these letters a little bit. I hope you must be able to remember more number of letters this time. We'll do this again, and this would clarify what's happening. I'm going to play the same letters again, and let's do this for the last time. These are the same letters which I just showed earlier. This time, definitely, you must be able to remember more numbers of letters. So just the topmost row is the first one, the second one, and the third one. So what's happening? Let's appreciate that our human mind works in this way. So basically, our reaction time depends on the number of choices given. If we are given so many letters, it's very difficult for us to remember. It's very difficult for us to react to those. But if we are making this presentation in such a way that so that we can relate it to something. For example, in the third row, these letters were relating it to something which we know. We were able to we were able to remember it. And that is what applies in many of the designs. I'm in the next slide, which is showing two website examples, the way people design these websites. These are two similar type of websites for the same purpose. I just put this for example. And the menus in these websites have been laid out in two different ways. In the first one, it shows us a very flat hierarchy. All options are upfront. For some purpose, probably this option is better. On the second option, on the right hand side, this website, there is a deep hierarchy because the options are not categorized. There are two levels at which you would be able to find these options, or three levels at which you will be able to find these options. Sometimes, if we have so many options, it's easier for us, we human beings, to react to those easily, so that we can assimilate those information easily. So again, why I'm showing these two examples is that designers or technologists have to take care how human mind works, and need to remember that how what these base models say, and based on that, define their design, implement their design, and give it to users to use. The question again is, so what we learned, one was the fixed law, is the movement. The second one is our reaction time, what's happening in our brain, how fast we are able to react to certain things. Um, does our reaction time always remains the same? Well, it also depends on the practice. It's based on the anticipation. It's based on certain muscle memory. It's based on these how our brain formulates certain things. And we have our complex optimization strategies running inside our brain, out of which we can find out patterns. So which means if I would have given this puzzle again and again to you with changing these letters, after some time all of us would become expert in this because we would be able to anticipate, we will be able to find out patterns, things like that. So these are few things which our how human minds are capable of doing. We can become more and more perfect. Uh, we can model that part as well. What we call as practice. So this is the third model which I'm going to present now and explain. The third one is called power law of practice, which means an obvious thing. The more you practice, faster you become. But why Dijon, who did a lot of experiments on different types of subjects, almost say 50, 60 years ago, when they came up with this model, they defined that there is an exponential nature, which means if you are learning something, at the earlier phase, your learning ability will be very fast. But at some point of time, you would also saturate. Your learning ability would go high, but how much you are learning would go slow. That is called power law of learning. So this is the third thing which we learn today. Um, I'm going to break here a little bit and just recapitulate what we learned. I'm not going to speak about more number of models. I'm just introducing the area, the fundamental method of cognitive modeling. There are so many models like this available for us to use. I'm not going to speak about those. I just explained three right now, and now we are going to see some application of it, which will help us understand how we can apply these models into our real life problems. So we learn.
Dr. Sanjay, your sound appears a bit choppy. Yeah, probably it's just a network.
Yeah, I should be better with issue. My throat is perfect today. Okay. Uh, so we are going to see some example ways of using these models so that we can appreciate how to use this in our problem statements, in real life problem statements. I'm going to talk about the case study, one particular case study which where I have used in my research is uh, use of cognitive modeling to design different types of Indic language keyboards. Indic language keyboard means where you type in Indian language. Your keyboard layout is Indian language keyboards, whether it's Marathi, Bengali, Hindi, Devanagari, or Tamil, or many different languages. All of this comes under the purview of Indic language. So I've worked on some research around this. Still, I've been working on this space in IIT Bombay lab for quite some years now. We're still working on this. And if there is some interest, people can collaborate with right people there. Why this topic? Because you know around 50% of our population. I'm just talking about India right now. 50% of this population are non-English literate. They are native language speakers, and native language as an input method for them is really important. It's not for people like me and you. We can speak in English. We know how to type in English as well, but it's for people who could not write in English or type in English. Forget typing, they can't even write in English. So if they can't type in English, they are missing out a lot of things because they are using mobile phones, and a lot of reports says that these are the users who are growing in India. We're talking only about India, but around the world, there are people in countries like Malaysia, Indonesia, Sri Lanka, Bangladesh. So many people who who are less English literate, but they are also using mobile phones. They must not be able to use these kind of these kind of activities like sending message, shopping online, which for us is so trivial. Like searching is so trivial. If somebody does not know how to type in English, they won't be able to do these basic tasks, which are important tasks in day-to-day life. So therefore, building language keyboards for them is an important tool on mobile. The question here is why really Indian users do not prefer to type in Indic language. Whenever we make talks in this space from anybody from our lab presence in this space, there was a TED talk as well from my supervisor in IIT Bombay, Professor Anuj Joshi. Uh, in those face-to-face talks, we always ask people, how many of you really type in Indic language? And we don't see, not more than 5% of people really uh, write in Indic languages. They are used to typing in transcription, transliterative languages, which means typing English letters and expressing in Indic language. Um, so, but as a designer, as a researcher, and as a technologist, we should be asking a question in a different way. What we should be asking here is, did we really give people those tools to type in English language well? Really, did we give them a good keyboard? Or really the keyboards are very difficult, that's why people are not typing. Also, we know that typing, in India, English is really aspirational. Like people who can type in English, even if they can't do proper English, they would still attempt in communicating in English because in India, really it's aspirational, more of aspirations, more social in nature. But still, yeah, the question really persists that really Indic language keyboards are they really tough? We can answer this question. We know all of us in this webinar, we must be speaking one or the other Indian language. This is Devanagari, a lot of us speak this language. And we know it is so complex. Compared to English, English has just 26 letters. This has what? Consonants, vowels, modifiers, conjuncts, directed marks. It's so complex to type and even write. The scripting style is so difficult. Like you need to use a consonant and then a vowel modifier, and then you get a syllable. So it's so difficult compared to English. Therefore, challenges in designing Indian language keyboard is manifold. Like the speed at which people can type on Indian language keyboard is almost one third. You would realize that really if you type in your language compared to English language. The accuracy is very low. The learnability of these keyboards is very difficult. These are very difficult to learn to type. And word completion and predictions are not well developed in these keyboards. Yeah. The other problem is when I was searching once on Google Play Store, I was looking for a Devanagari keyboard, and there were 200 such keyboards. All of these are just Devanagari keyboards. Forget about other languages like Tamil, Bengali, Malayalam, or Marathi. There must be even more. So if I just count all of those Indic language keyboards which exist in the Play Store, there are so many. And the thing is that there are different ways these keyboards have been designed. Some of these have swipes, some of these have multiple layers, some of these have different layouts. Like some are alphabetical layout, some are non-alphabetical layout. So the question always persists, like which is a good design? And from this question on, we started our research. We wanted to bring out the best design, the most optimal design for Indic language keyboard. How we should be achieving this? One of the approach which we took was doing the cognitive math. And through this case study now, I'm going to explain how we applied the cognitive. Okay, so the point is why really we need an efficient keyboard. This is a hypothetical situation which I have laid out here. So, for example, if I can just save 1 centimeter of my finger movement, uh, while moving from one key to other key, if I have a very efficient design, really, further, I'm going to save 5 centimeter of my movement, which means overall, if I have 100 million of active users of my keyboard, I can save so much of time.
Dr. Sanjay?
Exercise, we consider
Dr.
everything
Sanjay?
just yeah.
Yeah, so we lost the audio from the since the past slide. Could you please repeat
Is
that
this
slide?
fine now?
Yeah, the slide is fine. We lost your audio.
Okay. Okay, so I was here, uh, and I was talking about the approach of cognitive modeling. For a problem statement, a real life problem statement which we had in hand was that how do we design efficient keyboard? Design of an efficient keyboard should be how. And we approached it using cognitive modeling method. In modeling, we consider everything to be a black box. On one side of it, there are some parameters which would make this efficient or inefficient. Something like the layout of the keyboard, the different interaction methods which a keyboard has, the expertise level of the user, whether the user is a novice user for whom you are designing, whether you are designing for a novice user or an expert user, the language complexity, the size of the keyboard and the distance between these keyboards, and the position of each of these keys on the keyboard, and what you are trying to type. All of these are variables one side. On the other hand, you have speed of typing or accuracy of typing. I can see this as a problem, which is these are x, which means these are my dependent variables. Sorry, these are my independent variables. On the other hand, I have my dependent variable. So whenever you find a relationship between a dependent and an independent variable, we call that as a model. So in this problem, we have changed this real life problem into a modeling problem. Where,
Sanjay, we're not able to hear you.
uh, this is very, I'm sorry, is it fine now?
Yeah, now it's fine. Just from the last slide, please.
Okay. I'm moving a little faster here as well because we will lose out time because of these disconnections and other things. We have lost almost 10 minutes. So I want to take 10 more minutes to complete this. Do we have time or will be running short of
Sure,
time?
no issues.
No issues. Yeah, we do have the time. Yeah.
Okay. I'm really sorry. I don't know why the internet is not working perfectly. So there have been a lot of disconnections.
No issues.
Right.
Thank
So, and thanks. Keep bugging me if you are not able to hear anything or if you are not able to see anything. Please do bug me. I'm not aware of it. I'm not able to see. Okay, so I was here and I was talking about different influencing factors based on which you can design a keyboard. Like the question is, what is the scenario for which you are designing the keyboard? One of its example is how you are typing. Are you transcribing? That there is something which you want to type, you are copying it, or you are dictating, you are freely typing. What is the scenario for which you are designing? Again, for typing, some people do typing using thumb, some people do it through multiple fingers, some people do it through index finger. So there are different touch gestures which work using this. Then there are different types of input methods like voice input, like other input gestures, multimodal input. How you are designing your keyboard. Again, are there any prediction methods on the keyboard? uh, what is your language, which language you are testing for, and what is the level of expertise of the user. So there are so many such variables. So that I would say the problem statement which we had in hand was complex. Uh, Whenever you have a complex problem, real complex problem statement in real life, and you want to do a modeling out of it, you want to reduce the problem in some way. Now here, I just wanted to hint it to the budding researchers, students who are in this webinar. When you are doing your research, it's very important for you to scope your research. This is something what we did. There are so many research problems available in the single research problem which I just spoke about. The same research problems somebody can work for 10 years. But we need to break this problem into small. That is what we did right now. We focused on only three things: the design of the keyboard, the type of touch gestures, limited set of touch gestures, like defining keyboards which has slide touch gestures, which has long press touch gestures, and we were defining based on the level of users, etc. expertise. So these were the three types of variables which we wanted to measure, and based on that, we wanted to define the time performance model. This problem statement. The way we tried to is again breaking what typing is into micro actions. Now I'm going to refer back to what we learned in the first part of this talk, the different types of models and how you can make use of those in the cognitive modeling approach. So what is typing? Typing is basically a physical movement plus you are thinking something in your mind. You are reacting to something. You are planning your movement of your finger. You are searching for a key. You are recognizing all of these is happening. All of this complex activity is happening in your brain. And then you are moving your fingers. So you remember we spoke about multiple models. One of that model we spoke about was fixed one, which relates to movement of fingers. Now, what is keyboard? Keyboard is your movement of your finger from source to a destination. A source is a key and destination is a key. In what Fit says, Fit says is that the time of your movement. Here, I would just replicate this whole uh, model which fits develop into the area of keyboarding. So this is an application of a model which you are seeing. So movement of a finger, you might have seen in the previous video when I was explaining face, he was doing an experiment by moving his hand, but he can apply the same thing to the problem statement of keyboard solving because you are moving your fingers from one keyboard to the other keyboard. Therefore, the time of your movement would depend upon the size of the keyboard and the distance between these keys. So, can we optimize the keyboard in such a way that we can reduce the movement between important keys? Is that the way to approach? So, the other part which is going on in our brain. So unless our brain signals, we are able to search the right keys. We are not moving our finger. So I spoke about another model which is related to option selection. We spoke about
Dr. Sanjay,
the heat
are
slump.
are we still on slide number 45?
I'm showing a slide which has a title "Breaking the Typing into Micro Actions." Is that the
We are
one you are
still at
seeing?
slide number 45.
Is that
There's
it?
so many aspects to model text input.
No, no, I've moved. Are you able to see now, or I should restart?
Can I just quit the presentation and start again?
Yes, let me do
Sure.
that. Is that a problem with WebEx every time?
Uh, I'm seeing it this time. I didn't face this last time, so I'm not sure.
Yeah, because Google Meet works perfectly.
Yeah, okay, sure.
The WebEx, I don't know, I've never used it.
I guess today the WebEx platform might be having some issues.
Maybe it's the internet bandwidth which this requires. Anyway, right now I'm showing a slide which has title Breaking the Typing into Micro Actions.
Yes, we are able to see it.
Thank you.
Thank
Here, what I just spoke about was we are breaking the time of typing into two things. One is the movement of your finger. I was speaking about how we apply Fitch law into keyboard. On the other hand, I was also talking about. Um, I'm sorry, can you put off your microphone, please? There is a noise. Requesting you to put off your microphone, please. Okay, so let's proceed. So the second part of the typing behavior is about what's what's running in your mind, right? Am I on the? Are you guys able to see my slide still, or just one?
Yes, we are able to.
Okay, there is something in the background. There is some noise. I don't know why. Maybe somebody's microphone is open. It's okay.
Yes, I
Um,
have muted everyone.
yeah, now it works perfectly. Thank you. Okay, the other part which I was talking about is the uh, the reaction time. We spoke about the Hick-Hyman law, and we apply the Hick-Hyman law again on keyboard. Again, Hick-Hyman law is related to choice making. So when you're typing, you're actually doing a lot of choice making as well. You are picking up your characters, which means out of these characters, you have to pick one, which means your in your mind, what's happening is a reaction time, something like this, which can be defined based on Hick-Hyman law. Again, if you are practicing, if you are using the same keyboard for a longer period of time, you're going to improve your timing. You are going to be faster in typing. Therefore, your behavior can be again explained using power law of practice. So that is why I mentioned in the first part of the talk that there are some models out there which we can apply, use in our real life problems. So the real life problem which we have in hand was coming out with the design of the keyboard, and we applied these set of laws. It's not that there are only three laws, there are so many these different models available. The point is we need to choose which applies to our problem statement. Now we cannot apply this as is. We'll have to do some experimentation because you see these models have some coefficients. Now our problem statement can be defined by these models. We know what the equation would be, but we'll have to come up with our specific equation or specific constant for our equation. Then it would work. Then we would be able to simulate the typing behavior. So we did a lot of experimentation, a lot of mundane experimentation. I'll show in this video. I'm in one of the slides where you would see a lot of kids doing experimentation. There were three set of experimentation, one, two, and three, from three different models which you just saw. So for example, I'll just show this video. We did this kind of experimentation. Again, this experimentation is similar to what you saw in Fitts law experimentation, but on a keyboard. What it gave us the coefficients for our models. Uh, some of these experimentations are very mundane, which means an example is we asked a lot of users or subjects in our experiments to type just two phrases for 400 or 200 plus repetitions. So what we wanted to bring home here is when people type the same sentences again and again, they become expert. At least they remember the sentences. They are not making choices. Now, what is working out is their muscle memory, which means that we are trying to get the highest benchmark of the typing possibility. So this plot would get it clear little bit. So through experimentation, we were trying to get three different plots. One, we were trying to get the Fitts law kind of benchmarks, which means if you are tapping between two keys, ideally what typing is, you are tapping between multiple keys. You are moving from your one key to second key to third key to fourth key, which means you are achieving your target one by one. So just like Fitts experiment, we did this experiment with n number of keys and trying and see that how people behave. Then we ramped up some of the users, made them experienced users. These set of users continued this experiment for say 20 days, 30 days duration, and then they were experienced users so that we can benchmark their typing behavior. Which means in terms of plot, what I'm trying to say is on the y-axis is their typing time, which means a novice typer is can be the typing time of a novice typing person is can be represented using this red curve. An experienced typist would be something like this orange curve. So with more and more practice, a novice typing speed can be increased till the experienced typing. Now this is a hypothetical curve. We wanted a real curve out of this. We wanted to know how much practice somebody should get so that their speed should be something like this. On the other way, we can say that can be defined that given a keyboard, given amount of practice can be determine how much time it would take for a user to type on that keyboard, which means can be determined by how much time it would take for a user to type on that keyboard.
Dr. Sanjay, we have lost your audio.
Now, this is a layout of a keyboard which you see. This is the next step which we did. We are trying to come out with the cognitive speeds or cognitive times which each of these users use each of these keys in the keyboard. Um, for an example, the numbers which you see here in the red heat map is the total number of time. These were the average number of time taken for a user for a user to select these keys, which means from this kind of heat map, we were able to understand that there are keys which the users are able to target faster. Then there are keys, and some mostly the less popular number of keys, which the users are not able to target fast. Which means those are the keys where they are losing time. Yeah.
Yeah, your voice is really choppy right now. Uh, Hello?
Is this fine?
It is still choppy.
Uh, my end of the internet is perfect. Uh, how what would help you? Shall I disconnect, connect again, or what?
Uh,
I have 4 more slides to present, and I'll close.
yeah, it's okay right now. Yeah.
Is this fine? Then I'll continue.
It's fine, Sanjay.
Okay.
Please continue. Yeah, thanks.
Okay. So through this cognitive model, we were able to understand which parts of the keyboard people were learning fast, which parts of the keyboard they took more time to learn. For an example, if this is a keyboard which is an alphabetical keyboard, and if this is a Devanagari keyboard, then if I have a word to type, a user has a word to type which has a letter K. K is the first letter of the word mala. Then they were fast because they know this is an alphabetical keyboard where K is. So therefore the time for K is. On the other hand, if I ask them to type a word with a less popular key or a key which is somewhere in the middle, their time was more because they were searching for these keys. They were taking more time. That way, we were able to define certain cognitive time zones throughout this keyboard. An implication of this is for design of a good keyboard, we should keep the popular keys in right places so that we can improve the speed of the user's typing. So that was one of the implications. This is again what we're trying to do is there's a complex power law learning curve which we try to fit here. We skip this one right now. Like time. Um, Again, that was one of the keyboard. We have tried into multiple off-the-shelf keyboards, and all of these keyboards we tried coming out with the cognitive time zones, third key in multiple keyboards. Um, and with that, by combining the movement and by combining what's happening in our mind, we were able to understand what what is the model for typing, which means we were able to define the timing of typing in some way. So here what I'm showing right now, this is a plot which I'm showing, which is talking about the validation results. On the y-axis is the character per minute, which is basically the time, which is the speed of people typing, and on the x-axis is total number of time which was spent in doing the practice. So we tried evaluating our model, and we were able to see that for 3 different keyboards, our model was able to predict the real users typing behavior to an accuracy level of 90% approximately. Which means, in a layman's language, I can say that ideally, if you design a keyboard, you would be, if you want to see that how whether your design is good, you would go and test with the users. Then you would change the design and test it again with the users. But instead, through these cognitive models, we have created some we have created some simulation models which already has the users typing data, which already has the which can predict users typing behavior in terms of how much time it would take for them to move their finger, how much time it would take them to think and search for the next keys. So these models can predict the actual typing behavior to approximately 90%. An example here is, say, I'm showing a plot here which has three curves, and these three curves are the total time it takes for each of the characters to be typed from this sample phrase. So this is a Marathi phrase, and we ask the subjects to type a lot of these phrases. We picked this phrase just to evaluate our model results. And this model can tell you that which part of this phrase, by typing which letter, each of these keyboards, so the red keyboard, green keyboard, and the blue keyboard, these three blocks, each of these were losing time. So without doing experimentation, just through simulation, we could find that this phrase can be typed by users in these three keyboards at these approximately these performance. So we can see that the design of one keyboard is better than the other keyboard. So what we have tried achieving through cognitive modeling approach in this research is that we're able to model the motor movement. Motor movement is what your movement of your finger from one key to the other key on a keyboard. We tried defining that. We could define the new touch gesture interactions, such as tap, such as sliding, such as long press. These are different interaction methods which these keyboard designs use. So in future, if somebody comes up with a new keyboard which has these type of interaction methods, then one can directly use these models, simulation models, to test their designs. And then we were able to define different cognitive time zones, as I said. We also defined different learning models, like for a novice user, how these keyboards would perform. For an expert user, how would this keyboard perform? So these were some of the contribution of this research. And this is the last slide, and I'm going to close my talk here. What my hope out of this session is bring home just few points. Forget about the nitty-gritty details. Forget about the case study. I just wanted to bring just few points out of this talk. One thing is, the first and foremost thing is, there is a clear symbiotic relationship between and human beings. And it's very important to design technology, implement technology according to the capabilities of the human being, because we should understand how a user is able to use the product, how a user will be able to perform on a product. The capabilities are well defined. We know to what extent the capabilities of human beings are, and therefore our technology should not push them. We should design the technology according to human capabilities. The second one is, and the third one is, we human beings really are sophisticated biological computational machines. And therefore, our performance, our way of working can also be slightly predicted. The modeling approach is such an approach, which is to predict how a real user is going to use a product. And it can be predicted only to some extent. There is always an accuracy. The way we tried in our case study, which I showed you on a keyboard, we were able to predict till 90% accuracy, which is good enough level of accuracy. And the last point, of course, for people in this webinar, especially budding researchers, students. I would like to entice you all to explore this. This is a fundamental topic in human computer interaction. I don't know whether it is also a topic in psychology. People might be teaching that in the academics in psychology. But the information is out there, you can read about it. But the good thing is, you can always apply it to different problem statement. And that is what the point which I wanted to bring home today. And that is why I divided this talk into two parts. First, I wanted to explain the cognitive modeling as an approach and just gave you some examples and then showed you how to apply these cognitive models into a real world problem. I just wanted to advise you all to try this out, contribute into this space, and to collaborate. We are still working in this space of Indic language keyboard and design of Indic language keyboard. A lot of new activities we are doing in IIT Bombay lab. Professor Sanjay Joshi is the lead researcher who works in this space. I've been working here a lot of years. So, you know who are the people to collaborate. So, do drop a mail to contact. So, I'm going to end my talk. I'm really sorry for a lot of disconnections, lot of voice problems, lot of presentation problems. But yes, this is the way of working right now these days when everybody is locked down. Thank you all for watching this, hearing me out, and I can take up questions now as well as offline anytime. This is my email, you can always contact me. And I'm now putting off my presentation.
Hello,
Yes, please.
am I audible?
Yes, perfect.
Anand, go ahead. Anand, just unmute yourself. Before Anand is able to log in back. Sanjay, thanks a lot. Is
Hello. Yeah, yeah, I'm here.
yeah.
Yeah, I'm back. I'm back. Yeah, so we have a few questions. Dr. Sanjay, I'll go over them. If you can answer them. If anyone have any questions, please post them in the chat window. So we have the first question from Deepa Adiga. This is regarding the FITS experiment. The question is, wouldn't the time depended on the appearance of the source and destination? Uh, okay, so this says, wouldn't the time be dependent on the appearance of the source and destination, like color and shape and things like that?
Yes, that's a good question. Uh, it is true that it might depend upon the color and many other factors, like what is even the shape. If I talk about the example of keyboards, the shape of the keys would matter a lot. Now, going back to the base experiment which Fitz did, those were very straightforward experiments wherein all the other variables such as shape, the color, and other things were already controlled. And therefore, the only stimulus which was being changed, the parameter which was being changed was the distance between the source and the destination and also the size. The other parameters were controlled, and then only you get a cleanly defined model like this. But if you have other factors in place, definitely those will come into picture. It's very difficult to do those kind of experiments again. And therefore, for our experiment as well on keyboard, we were very specific. For example, we were very specific in terms of not showing different colors. We were very specific in terms of all the keys should be of same size and shape, which is an obvious thing on all keyboards. But additionally, which we tried, which we thought which we cannot control, is the directionality. For example, if you are moving your finger in a vertical direction, or if you are moving your finger in a diagonal direction or a horizontal direction, probably your timings would change. On a keyboard, you'll have to do all. You'll have to do a combination of moving your fingers across in all directions. And therefore, in our experiment, we did take care of it. So the only additional thing which we took care in defining our fixed experiment was only the angularity of it, and which we already incorporated into the an accessory model, which adds up to the fixed model, an additional constant. Yes. So hope this answers the question. In summary, yes, all of these are variables which really changes the performance of the user.
Yeah. So we have another question. It is regarding the Indic keyboard design. So Hiranmay Ghosh is asking, do you model a novice user and an expert user differently?
Okay. Uh, Good question again. So generally these models, I can answer this based on uh, how modeling works. Basically, the models, the basic models which you saw, the fixed model and the Higgs law model, all of these models works on a premise that your user is an expert user. Right. Uh, so all these basic models are for expert users, and that is why uh, we tried adding one more component to this model, which is power law of learning. An example is that a lot of work has been done around cognitive modeling. It is not right to say that this is the first work which we did on cognitive modeling of keyboard. No, cognitive modeling on keyboard has been there as an area within human computer interaction, and people have published a lot of work almost a decade ago. But all of that work has been done on QWERTY keyboard. Now, consider this, that people who type on QWERTY keyboard are almost at the level of not, you can't call them as novice because their typing speeds are pretty fast. Even you can take yourself or me or people in this webinar, our typing speed on a QWERTY keyboard is sufficient enough to call us as somewhat an expert users on mobile keyboard. But that is not the case for Indic language keyboard. We have not seen anybody who is an expert typer on Indic language keyboard. And we are designing, and in the beginning of this talk, I said that we should design this technology. Here, technology is a keyboard. We should design it for users to use. And who is our user? Our users are these 1.3 billion users in, say, India. Maybe not 1.3 billion is not, maybe millions of users who use an Android keyboard or different phone keyboards. Um, they are not expert users, they are device users. And that is why we thought of modeling our research problem for all sets of users. And therefore, there is a component to our model which is power law of learning, which means our model can tell you that what we can define that the speed of a novice user would be something, and a speed of a moderate user would be something, and a speed of an expert user would be something. So that is the component which is going to change based on the expertise level of the user. So hope this answers the question. In summary, the answer to this question is yes, our model takes care of the range between novice to expert. But again, novice and expert are not discrete range. It is a continuum. You can't define who is a novice, who is expert. But uh, this model takes care of the amount of practice somebody has done. It is an operational measure of somebody is novice or expert. Based on how much of practice you have done on a particular product makes you an expert or novice. So it takes care of it. There is a variable which takes care of this in this model.
Yeah. Thank you. So we have another question. So this is from Hiranmay Ghosh again. Do you base the design on usage statistics like in QWERTY keyboard?
Okay, so let me understand this question. So first of all, The model is not for QWERTY keyboard. The model is specifically done on Indic language keyboard. I won't even say that this applies across all different Indic languages. It applies to one particular Indic language on which we did the experiments. Okay, it can be generalized to some extent. We have the methods to generalize this. We can also try and generalize this to other Asian language keyboards like Chinese or things, but I won't say that currently the model is tuned according to this. So this is not for QWERTY keyboard. This is for Indic language keyboard. Um, now, the other part of the question was asked related to usage level, usage data. No, this is not based on the actual usage data. It is based on the usage data which we collected during the experiments, which means prior to defining these models, the model should be based on some user data, some real user data. So we collected these user data by running several experiments, giving them different tasks to type, and then we analyzed and then we tuned this model. So it is based on real users data, but not their real usage on their phone. It is in the experimental environment. We collected this data and created these models.
Thank you, Dr. Ghosh. We have another question from Partha. Can you provide data on the efficiency or speed of the Swarachakra layout versus the current standard Gboard's Devanagari keyboard?
Mhm. Again, good question. We have presented some of this data by comparing multiple keyboards in some of the research papers over the last few years. Um, Google's Gboard is a different keyboard, a different layout, and the layout for that has changed recently. I myself work in that keyboard as part of Google and contributed to that. As a lab testing, we have not tested it directly and head to head with any other keyboards. So there are two ways in which we have done testing. One is through conventional method. In one of the projects which we did in IIT Bombay lab, we have stress tested all of these keyboards, multiple uh, popular keyboards such as Swar Chakra. You know Swar Chakra. Somebody has mentioned it. By the way, for other people, Swar Chakra is a keyboard which has been designed and developed from scratch in our IIT Bombay lab. It was released for Android almost 8 years ago. It has a lot of users now, more than millions of users, and it's available in multiple Indic languages. It's only Indic language keyboard, a popular one. Now, the question again is, if I take this question very generically, what the person wants to know is whether Swachakra has been tested and its performance has been tested with any other keyboard, for example, Google keyboard. Yes, we have done that, and from our test results, we found that it is faster and it is more accurate than other test sample keyboards which we tried out. Provided we have not used any prediction into it. So there are some keyboards which has prediction as well. So if you start using those prediction, your performance sometimes increases, sometimes it decreases. So just layout to layout comparison, we have done it using experiments and we have found that it is faster. And through cognitive models as well, I showed you in one of my slides where I was comparing three different keyboards and for a particular phrase, we saw that the time for typing that phrase on a search engine keyboard was faster than the other keyboards.
Yeah, thank you. So we have another question from Sumant. He is asking, does mean cognitive time for a particular key depends on the words you are using? How are you choosing these words for testing the users?
The definition of the mean cognitive time in this experiment was generic, which means that from the terminology, the name of the terminology itself is that it is mean. which means that it is for all the corpus letters and all the corpus words which we give these users to type. So by the way, this is from the experiments, which means that during the experiment we have given around 20 different long phrases for the participants to type continuously, and they would type this every day for next 20 days, and we were collecting their data. And these phrases were created in such a way that before doing this experiment, we actually designed these phrases in such a way that first of all these phrases mean something. Secondly, these has all combination of letters, and this has combination letters which would follow with a correct combination or good mix of other letters, and which would also mean that we would make those words which would make the users move their fingers across the keyboard. There were words which has consecutive letters such that their finger movement will be small, their finger movement will be long. We were making diagonal movements, we were making horizontal and vertical movements. So these phrases have been selected in such a way that we were able to test all of these aspects. This is not known to user because we just gave them these letters. But when we analyzed their data, we came out with this terminology called mean cognitive time, which is basically when people move their fingers from all of these locations, and all popular letters as well as less popular letters, conjuncts, and all of these different less popularly used letters, including those as well. Whatever is the time, that comes out to be a mean cognitive time. And based on that, we are basing. So, so in order to just summarize what I just said as the response to your question is, yes, the mean cognitive time has been made really independent of what the phrases were, because the phrases were made very generic, and therefore the mean cognitive time really represents the actual performance, not very much biased to what was given to them.
Thank you. Before we go to the next question, if anyone have any questions, kindly post them in the chat window. We have another question from Deepa Adiga. Would the behavior time depends on the number of languages the user knows? How does switching between languages influence this?
Okay. So this, as I said initially, when we tried defining the whole problem statement of the fact that we wanted to design the best Indic language keyboard, language was one of the aspects which was a difficult variable for us to tackle, because we could not do experiments in all different language. And again, the layout which I have, optimal layout out of this model which I have for Devanagari, for say Tamil, it might different. For Kannada, it will be different. So, because the words in these languages and the vocabulary in these languages are really different, therefore, we thought that we should keep that aside. We did not use that as one of the variables. So, language was not used as one of the variables during the modeling. We completed this model only on one language, and that was Marathi. And again, Marathi is uh, script is Devanagari, so therefore it is applicable to Marathi and Devanagari. We can't say that whether this model will work as is for Tamil as well, but the method remains the same. Somebody can design the model for Tamil, somebody can design the model for Bengali, and somebody can design a common model and see what is the real variations across the languages. Uh, the clear question here, which was asked in terms of the learnability aspect, which means if I know multiple languages, then does it become difficult? Actually, I don't know this one because we have not tested. But my gut feeling is that more you know, it would be difficult for you to unlearn certain things and learn something. For example, before doing these experiments myself, when I did these experiments on my own self, I did not know the language Marathi. I know only Devanagari. But since typing on Marathi is actually Devanagari, my speed of typing was way lesser than somebody who is a native Marathi speaker. So I did not know that language, therefore my speed is less. But I'm still typing the same characters, which are Devanagari characters, without even understanding what is the meaning of the words which I have typed. So language plays a role. How much? I'm not sure. We cannot quantify that. But again, this question really raises a good problem area, which means it's an open problem somebody can actually work on. And it's an important area. Thanks for that question.
Yeah. So we have another question from Santosh Kumar. He's saying good evening, and I'm a research scholar doing research on detection of human object interaction in an image or video using object detection technique. Could you please share your thoughts on the same so that it can benefit me in my research?
Okay, so this is slightly divergent. This is slightly divergent.
Right. Yeah.
Santosh, will it be okay if we can talk offline on this one? If you can drop me a message and then we can connect and let me see how I can help you. I'm not an expert in the area of image video processing, but let me see if I can help you with the methods or I can connect you to the right people if they can be of help to you. I'm not sure. Right now, at fingertips, I do not have response to your question. I'll have to just understand so that I don't answer you wrongly.
Thank you, Dr. Sanjay. So we have a comment from Deepa. Thank you so much. The session has been informative. Good to see implementation of predictive modeling in HCI. I need to join one more call. So, okay, she's logging off. Yeah, so we don't have any more questions. So I have a kind of rapid fire kind of questions for you. So this is like think less and answer quickly, like one sentence or something. So it's just four questions. You just have to like tuck tuck tuck. You have to answer them. So the questions are pretty simple. So the first question is, when did you develop an interest in computer science?
Almost 15 years ago.
Would you like to share some experience that led you to computer science?
The working systems, the thing, which means things if it works automatically and if you can program it differently, it works in a different way. You have a capability to program certain things in different way and the output changes. So that is really fascinating for me as a kid when I tried out making programs very early. So that was really fascinating.
Yeah, thank you. That is really amazing. Yeah. So the second question is, what made you develop an interest in human computer interfacing, and why did you decide to specialize in UX?
Of course, this is good. I started working as a research scientist in a company in ABB. This was almost 6 years ago, and this was my first project where I tried working with um, on interfaces, and it thrilled me a lot. And then I started exploring this space, and I understood that in order to work in this space, I need to learn, I need to gain some knowledge, and therefore I thought I should go for an additional degree, and then I took this opportunity to go for a PhD in this space, and I am really enjoying it. This is a great field to work on, and the intersection between the technology and how users use it. That's, that is something which thrilled me and really interesting.
Yeah, thank you. So another question I have is, a lot of movies have this cool UI, UX kind of things, and are there any movies on the top of your mind that has the coolest UI, UX?
Don't go over the movies, by the way. So there
Anything
are
that just yeah, anything
uh,
that came to your mind when you hear UI, UX?
So I'm not thrilled so much with the movies and the use of interaction on news, but a few years ago we saw this Minority Report as a movie which had a cool design or cool use of interaction that did thrill a lot of people. I think a lot of people in the webinar would also relate to that, but yes, that now at present there are a lot of products out there in the world. Big companies have come up with a lot of products like virtual reality is now a reality. You can actually create your animals in front of you, physical size animals. Um, and also 3D printing has come up. And a lot of these technologies have improved in such a way that we do not have to refer back to movies. We have gone beyond that. So I feel that there are a lot of things people might be doing in places in the world. We should refer to that if we are ready to that.
Yeah, that is a very interesting thought. Actually, for those who don't know what Minority Report is, it's a Tom Cruise movie. Just go and watch it. It's really good. Another question I have is, what do you do at your free time, apart from researching about this and creating cool UX things, before the lockdown and after the lockdown? I mean, during the lockdown.
Yeah, multiple things I do before the lockdown and things I've changed during the lockdown. Yeah. So before lockdown, um, I try out singing. I also play the guitar. I used to do that earlier. That was my favorite pastime. After the lockdown, when there is nobody to listen to my guitar, people will get bored inside. I have developed two different interests. One is cooking. The other one is awesome one. I have developed interest in stock trading. Like, this is a great time to do stock trading. I'm earning good there because the market is down. It's flat. It might go down again very soon. So it's a great time to do stock trading. I've learned this over the last 2 3 months. Till I'm in the side of profit, I'll continue doing this. I'm getting addicted to that.
Okay, cool. Yeah, thanks a lot. That's all I had. We have a request from Santosh. If you could share your contact details, probably would you like to share your LinkedIn URL in the chat window? It will be easier for
Sure.
people to access.
Yeah, this is my contact detail. I will share my contact detail and this is me. I
Thanks a lot.
shared.
Yeah, that's all we had from our side. It was a great session. Thanks a lot for joining us today. Would you like to have some closing notes on this, and then we'll go ahead and.
Of course, and first of all, this was a great session. Lot of good questions in the end. I was thinking probably because of a lot of disconnections in between, when you guys were not able to see the slides, and things, people might get disconnected. But thanks for these questions in the end. I really feel that you have enjoyed it from the questions itself because the questions asked in the end were really deep. And thank you, um, Vishwas, for hosting me for this session. This is a different kind of topic which I have brought in. It is more related to intersection between design and technology. And I think from my experience, I can speak about it because, as I said, I was a technologist earlier and now I've moved into design research as a field. So it's an important space to be in at this time. And the work on human-computer interaction in India is still very rare. Therefore, my request and my earnest request to the students and the budding researchers is that do explore this as a space. It's a very interesting space, a lot of things to work. It's a modern space to work on. So therefore, this is a great space to work. Be in touch with people who work in the space. For example, there are people in IIT Bombay. You can get in touch with me and can introduce you to people. There are courses out there which you can learn. So interesting time and interesting space to be in. That's the only thing which I wanted to bring into this.
Thanks, Sanjay. That was a really interesting session, and I'm very sure participants would have a lot of stuff and learning to take home. And also, thanks to all the participants for taking time out to attend this session and also posting so many interesting questions. And we will be bringing more webinars in the weeks to come. Please follow us on LinkedIn, Facebook, and Twitter, and we'll share all the details there. And also, thanks, Anand, for being a great host today as well. And once again, Sanjay, thanks a lot for your time and a really great session. We'll keep in touch with you for further collaboration and I'm very sure this will be very fruitful. And that's it from us. And stay home and stay safe. Thank you, everyone.
Yeah. Thanks a lot, Vishwas. Thank you everyone for joining on call. Thank you, Dr. Sanjay. So let's officially wind up the session. Have a great day. Have a great weekend. Stay home. Stay safe.